Okay, so good morning, class. All right, so I'm just gonna do a self-introduction. So I'm Tommy, and this is Jingan, and today we're gonna teach you ways, right? You will never lose in a Tic Tac Toe game. All right, so our inspiration of doing so, right, is because we always lose in Tic Tac Toe while we were younger, lah. So we're gonna help you to never lose to your opponent. All right. So for now, we need a volunteer to have a friendly game with the board. So anyone want to volunteer? Eh, just right. Eh, come. Eh, just nice. You late, right? So. Okay. Just play the game. Just play the game.
Okay, so currently, right, is never mind. It's okay. It's gonna play a game with the Tic Tac Toe with the AI, and then we'll just see how it folds out.
Yeah, you lose in everything, Hey, tie. Not bad. Okay. Go back. Alright. So can anyone guess what algorithm or the strategy did the bot use to not lose to their opponent? Anyone? Alright, okay, never mind, it's okay. So it's actually the Minimax algorithm. Alright, so Minimax algorithm is a decision rule for minimizing the possible loss for worst case scenario. So the main goal of the Minimax algorithm is to minimize the maximum loss and to maximize the minimum gain. And Minimax algorithm can be applied to tic-tac-toe, chess, stocks, game theory, and also operations management. Alright, so the first step of Minimax algorithm is to create all possible scenarios, then to locate the terminal state, which is also the end state of the game, then assign scores at the terminal state, and also examine the scores and make decisions based on the Minimax algorithm. Alright, so this is an example of a tic-tac-toe game with 3 possible moves left. So X will be the AI and the circle will be the human. So it's currently the AI's turn. Alright, so these are the possible moves that the AI and the human can make to the current state of the game. Okay, so like a professional chess player, this algorithm actually sees a few steps ahead and places itself in the shoes of the opponent. So it keeps playing ahead until it reaches a terminal arrangement, which is also known as the terminal state, resulting in a win, loss, or tie. So these are actually the terminal states of the game. As you can see, the results are either win or loss for this example. So for now, I'll pass my time to Jingan, who will be talking to you more about assignings of scores at a terminal state.
Okay, hello. Thanks, Tommy. So I'm Jingan. Okay, so now we'll be moving on to step 3, which is assigning the scores. So as Tommy has mentioned, right, there are 3 terminal states in tic-tac-toe, and that is a win, a draw, or a loss. Okay, so simply put, when we assign a score for a win, we're going to give it a positive 10, a draw 0, and for a loss negative 10. Okay, so quite intuitive. Okay, next. Okay, so as you can see here, currently from this example, okay, we have 5 terminal states, and just nice, okay, there's no draw. Okay, so we'll work from the one to our left. Okay, so when there's a win, we'll assign a score of positive 10. Okay, can. Okay, so we give that a positive 10. And for the remainder, okay, we'll just assign the negative 10s and positive 10 to it. Okay, next. So for the past 3 steps, right, we haven't really come to a decision of what the AI or us should be putting our X at. So now we'll come to the Minimax decision, which, remember what Tommy said, is to minimize the maximum loss and maximize the minimum gain. So how this algorithm will play out is, when it is the AI's decision, okay, the AI will be selecting the maximum score, okay, based on what we assign. And when it is the human's decision, okay, the algorithm will be selecting the minimum score. Okay, so do not worry about whether this is too confusing or what. Okay, so I'll just walk you through it. Okay, so we'll always start off with the end state. Okay, so we look to our right. Okay, the 4th column. Okay, as you can see, the end state, terminal state, is assigned a score of positive 10. So we will always bump the score upwards until we reach our final decision. Okay, so positive 10, okay, there's not much of a choice here, so we'll bump that up to the next third column. Okay, so now we are faced with a decision. Okay, there's a one where the human can put the circle in the middle, or the human can put the circle at the top. Okay, and it is the human's decision, as you can tell. So based on the Minimax algorithm, okay, as we know it, the algorithm will select the minimum score when it is the human's turn. So of course we'll bump the negative 10 up. Okay, so now we look at the last one. Okay, a choice between negative 10 and negative 10. Simply put, negative 10. Okay, so now the final decision that we have to make. Okay, where do we put our x? According to the Minimax algorithm, when it is the AI's turn, we'll pick the maximum score. So easily put, positive 10, so the algorithm will place the x in the middle. Okay, so back again, okay, the Minimax algorithm, 4 simple steps. 1, to create all scenarios. 2nd, okay, to locate the terminal state, which in this case is a win, tie, or lose. 3rd, to assign the scores at the terminal states. And 4th, examine the score and make that decision to never lose in a tic-tac-toe game. Okay, so we reach a certain conclusion here. Okay, it's a very, very simple algorithm and exactly why we want to share it with you. Firstly, first point of conclusion is complexity. Okay, as you all saw in step 1, right, creating all scenarios. I'm sure we did counting last week. Okay, if we started on a blank canvas of tic-tac-toe, okay, and we count every single scenario or possibility, okay, it's going to be a lot and too many to handle for average human brain. So exactly because of that, okay, we reach back to our conclusion last week, which is why we need calm thinking. Okay, we know the logic behind it, but we need the computer to help us to generate all that respective different kind of scenario. Okay, second, class objectives. Okay, as me and Tommy are going through the Minimax algorithm and we are creating that scenario chart that you saw in step 1, okay, it looked a little bit like decision trees and whatsoever that might be taught in week 7. Okay, we are unsure. Okay, we tried to venture more into it, but we don't want to complicate things. So hopefully, looking at that scenario chart and the knowledge of trees or whatsoever, it excites everyone here to look forward to what Prof might teach in week 7. Okay, and lastly, philosophy. Okay, I'm sure there's a heart-burning question among everybody. Is there a guaranteed way to win tic-tac-toe? Because remember, we emphasize on never losing, but what about guaranteed way? And to many things in life, okay, the answer is no. There's no guaranteed way of winning tic-tac-toe. Okay, but maybe if we keep working hard and try hard, one day we'll be the one dictating the winning solution. Okay, so with that, okay, we hope that you at least learn something about Minimax theorem, which is you want to minimize the maximum loss and maximize the minimum gains. Correct. And with that, just some references when we put up the slides. And thank you so much for your attention.
Questions for them?
Yo.
All the states for tic-tac-toe.
Sorry?
It's quite small, right? Do you compute all the states for tic-tac-toe and how many there are there?
Okay, so if you search online, Google it, straight away you'll find the total number of states for tic-tac-toe. Did you manage to do it? Yeah, okay, but we tried to compute it using our counting. Trust me, I failed miserably. I don't know about Tommy. Reason being is because the terminal state can be reached without having to fill all the blanks. Okay, so I tried to do based on what I learned last week, all those permutation, combination, and try to do a total number of scenarios. I failed terribly because you can literally end tic-tac-toe when maybe put XXX at the opponent move. So it can end at any time, you know what I mean? And I wasn't able to do it. But just Google it online, you should be able to find that vast number. When you have that vast number, I'm sure average human brain cannot really expand and think that far to assign scores and then decide on things. So that's why we need the calm thinking. Thanks for the question. Anyone else? Okay, if not, thank you so much for your attention.